So Rohit, and again we are back with the hands-on demonstration of the project we were building with. It was insurance claim check with automation of agents with Amazon Bedrock Agent Core and other stuff. So if I give you a little context about the project which we are working on right now. So let me pull out first the document, the cloud architect diagram, what it is. So first of all, uh, understand by an analogy. Let's say you are driving a car in a highway and suddenly you crash your car. You are stressed. You take a photo of any part of your car which is damaged. You feel you immediately contact your insurance company because you're stressed up about the bill, how much it will cost to repair the car. You immediately your insurance company asks you to fill up some forms, and like you again visit their website and you fill up the form, you click the photos of the damage and everything, you put your car model number and xyz details, then you wait and when will then someone will check your all the papers, documentation, and they will cross verify your policy numbers and everything, and this whole process of paperwork and other things will take time, and at the end after 2 or 3 days they will say that if you are covered for the claims or not. So here is an idea which Amazon proposed in front of to to overcome this manual paperwork into AI agent kind of stuff, where we can automate this entire task within a second, so employers can take a data driven decisions. So let's say the diagram you are seeing in front of me right now, in front of screen. Okay, so what if instead of waiting 24 hours or more than that, you get an answer within a second? Okay, today we are building, and today we are building a data driven claim checker system. You give it a claim, it compares with the policy that you've been registered with, and tells you within a second that your claim is approved, denied, or we will look in, it will take some time to look into it by for a human to review it. So yes, and doing it, so we can say that by following this architecture in front of my screen, we can say it is a scalable, secure, and aligned with AWS well architect framework. And I will keep this so simple so you can actually enjoy the flow, and it's basically this architecture can be made in a different way. We can use AWS Lambda function and text track and other things, but the main motivation of this video is to just how you can use foundation model to verify and to automate the process. And there are other pros and cons of this architecture, I will explain you later. But let me just give you a flow. First of all, users visits a website, website with mobile or laptop channel, and that laptop, we are securing our entire network with Amazon Web Firewall, which is basically protecting our entire platform from DDoS or other malicious activity. Then our front end is hosted on S3 static website, where we are just globally hosting it with AWS CloudFront. Whether you are sitting in India, UK, or Canada, you can easily get the website within seconds with a low latency. And we will have their customer portal within, we can make within AWS Cognito, so entire sessions and tokens will be secured on our platform side. So once user feels that he needs to submit a claim, he directly fills up a form from the front end website and clicks the photo and upload all the data verification, and that data will be stored into Amazon S3 bucket. And here we are using an EC2 machine to host our entire monolithic architecture right now. So what it generally does, it is just cleans the data, extract, let's say some user upload the PDF of a police report or other thing. So it pulls out text from the PDF using library py PDF and other things. Other thing is we have used an prompt template which industry best practice. Bedrock says that instead of hard coding the template, you should use prompt template, so it is reusable if we need any other operations. So we are giving the entire PDF data to Sage to Amazon Bedrock to find out what are the key value pair relationship between the thing. And once we have like some information from raw data, we are giving that raw data to again to the another foundational model to find out some summarization, in it will analyze the raw data, it will see our policy and policy report, and then after it will generate some kind of responses, whether that insurance claim was accepted or rejected, and that entire thing will go back to to the user. So this is just a basic architecture how to use Cloudy for foundation model for doing your claim thing. Let me show the hands-on thing with you. So let me pull out my code. So I will share the GitHub code with you. So what I have done is like I have using Python Py. So activate. I'm activating my virtual environment and Python backend.py. So here I turned on my backend Flask API server, and I'm turning on now the same project. I have set up the React app inside the same project. So front end, uh, and clear npm down there, npm down start, clear npm down start. So here we go, and so it's just a quick summary. When I say the data driven means like uh, we are using the claim data and policy to decide whether the claims will be accepted or not just like a guesswork. It is using proper policy. I can show you policy as well. So what we have done, we have hard coded the policy, whether in future we will integrate directly Bedrock knowledge bases and other thing, but right now we can just integrate text data. And let's say policy document, like it says that collision pay for damage thing, and filings will be only claimed within 14 days of incident, and other rules like we can integrate it over here and claim valid, claim invalid, then other thing. So you can have a look. So let me show you direct front end interface. So I have loaded a two journey, happy journey and sad journey, where let me just like if we put this is like a raw data pulled out from PDF report. Let me show you. I generated one PDF reports. There was no any public data set of claims available, so I just generated this data from randomly from the thing. So let's say this is like a claim report or a claim document. Any insurance company will provide this kind of thing. This is just, again I'm telling you, this is just a random generated report. Okay, necessary fields like claim ID, incident date, and filing dates, policy number, and what was actual incident happened, damages and thing, damage of photo and other thing. And let's say if we give this data to the what what my application do is it will pull out all the text data from the PDF and pull out images, and it will upload to S3. And so if we give the thing like a compare, so it will call the Bedrock APIs on the backside, and we will see that comparing against the rule. Like by saying this, Cloudy has says that confidence level is 90, and it document is verified, and we are ready to provide them a claim, and filing details and all the details are passed. And it has also given the reasoning. The claim was filed within 14 days raw. The damages are covered under the comprehensive cover and police report and other things. Let's say if we refresh this thing, and if we apply it for the bad journey, how this thing is working. So let's test the bad journey as well. So what it says that the claim was filed late. Okay, police report is required but missing estimated cost over 2000. So we have tested both the side, and you can play around with this. I have also build a application form where you can upload the things and play around. And that's it. So insurance company claims, and going further we can improve this if we require, like if we want to do a serverless architecture, yes, we can do it. And I have provided entire code, and if you want to see the document, this is my S3 bucket. Okay, and here we go. Here is the same PDF. And for your review, I am also uploading my code. You can play around with the cursor, play around with this thing, and have a look. If you can do it better than me, you should definitely do it, and share this your entire work on the LinkedIn, or you can fork my GitHub repository and work on top of that. See, in this kind of Gen AI projects, sky is the limit. I was reading one of the LinkedIn post, and some guy asked like how you will verify whether the document is not fraudulent. Some guys are not using any any fake documents. So to resolve that solution, we can also integrate Amazon Tax Track and Amazon. There is one more service of Amazon. Uh, that particular AI service is like, yeah, Amazon recognition APIs. We can use that service to see whether a document is fraud or not. Images like someone may apply yeah, like AI generated images of car crash or something. We can using Amazon recognition API, we can also temper neglect this kind of things. But yeah, the main intention of this project was to just implement a foundation model and do reasoning of the thing, and that's it from my end. Keep building and share your results on LinkedIn. Tag me and enjoy the learning. Thank you.